During your Lab 2 session, your TAs demonstrated how to construct a resistor LED circuit in series with a DC power supply. This is a recap of that process so you can review it in the future. So the circuit schematic looks like this. You have your DC supply connected to a resistor connected to an LED. The schematic is your guide to tell you how to construct your circuit. In order to construct it, we're prototyping, so we'll need to use our breadboards. In your lab manuals, you'll find a copy of this figure. This figure shows you that there's connection points across the rail, that they do not connect across between them, but they connect longways. That is the rail. And in the center, there's groups of 5. That connections are made between the spots in each row in the group of 5, not across the gap though. So we're going to start by placing the resistor. The resistor has 2 leads on it, one on each side. These bend. You should bend them around to make it fit the way you want. It does not matter where you place it. The only part that matters about placement is you don't short it. So I will demonstrate here what a short looks like. Both of the leads for the resistor are in the same row. When they're in the same row, it connects to itself. That will force it to not work. So we'll move one of the leads to a different spot. So now you can see we have one in that row and one in that row. They are not connecting each other. That will make the circuit appropriate. The next element in the circuit we're going to make the connection for is the power supply, because that connects to one end of the resistor. I will be using the rails. The reason I like using the rails is because it keeps things organized. Speaking of keeping things organized, you might notice I have 2 different colors of wires. The color of wire does not matter. However, they are useful to keep things organized so you know which part of the circuit is which when you're debugging. So since resistors are not polarized, it does not matter which side of the resistor I make the connection to power. To make the connection, I'm going to push the wire into one of the spots in the same row as the resistor. This allows it to make a connection. Then I'm going to take the other end of the wire and push it into a spot on the red rail. The reason I chose the red rail is it has that little tiny positive symbol. Red standardly is referred to as being positive, or where the supply comes from. We will connect this to the actual DC supply, which is done with the Arduino once the circuit is connected. Now we're going to go ahead and look at the next element, which is the LED. You'll notice I marked positive and negative on it. That's because an LED is polarized, and that means that it matters what direction we put it in. In your lab manuals, you'll see this figure. This figure tells you there's 2 different ways that you can tell the polarity. You can look for the dent when you're looking down on the top of the LED, or you can look for the short lead. The short lead is the negative one. That's going to tell you the polarity. So I have my LED, and it's a little hard to tell, but we can see this lead is slightly longer than the other one, based on the fact that I can turn it all the way around when I put it on my finger. So the long side, the positive side, is going to connect to the resistor. So I'm going to find the row of the resistor, and I'm going to put the positive or the long lead on the same row, and I'll put the other end somewhere else. So you can see they're in the same exact row for the connection point, and then the other is off somewhere else. Once that's in place, we're up to our last step in the circuit construction, and that's connecting the LED's negative to the ground piece. Negative is often referred to using the ground color of black. That's a standard notation. Color does not matter. but you should keep it organized so you know which color is representing which. So I will do the same exact thing that I did for the power and for the other connections. I'm going to go to the same row as the lead I want to connect to, and I'm going to push the wire in. Then I'm going to take the other end and I'm going to push it into a hole by the blue line, which is what's representing the negative symbol in the line notation there. This is going to tell us that this rail will behave as the ground. And once I have the circuit built on this level, I'm going to turn to my Arduino. The Arduino is going to be where we get our connection points from. So you can see that there's little numberings and lettering all over the place. These are actually telling us what pin or connection point corresponds with which behavior. For this circuit, we need the ground and the 5 volt to provide us with the power, which is what we're doing right here. So keeping with my notation, I'm going to take the wire and I'm going to plug the red one in to the pin that corresponds with the 5 volts. And these header pins here connect the same way that the breadboard does, that you just push it in the hole. Now the other end of the red wire, where my power is coming from, is going to connect into the red rail. This is now allowing the entire red rail to be supplied with 5 volts, that anything connecting there will have that voltage. The next part that we need is the ground. So we've got several ground points. For convenience, based on how I have this laid out, I'm going to use the ground up here. It does not matter which ground you select. A ground is a ground is a ground. So then we're going to connect this into the blue rail, because that's the rail that we're using to represent ground. Once all your connections are in place, you should double check that everything has the correct polarity and also that they're in the correct spots so you don't have any shorts or that you're not off by a row. Once that's done, I'm going to go ahead and plug my USB into the Arduino, and you can see the light has turned on. The LED is on. That means I successfully have built my resistor LED series circuit with a DC supply. It's DC because it's stable, it's direct current. It is not alternating or changing. If you have any questions about how to construct circuits such as this, please make sure you see your TA or instructor during appropriate office hours or your recitation section.